Hello everyone, this is Mr. Appel, and today I'm going to give you a little refresher about synthetic division. You may remember doing synthetic division in Algebra 2, but I'm going to give you a little refresher and show you something you probably didn't see in Algebra 2. So for starters, I've got this division problem, which you could do by long division, but synthetic division is a shortcut. Keep in mind, synthetic division only works when you are dividing by a linear factor. So this is a linear expression. It's written out of order, which we're going to deal with in just a second. But only linear factors does synthetic division work with, at least for our purposes. So in long division and synthetic division, you want everything to be in standard form from highest exponent to lowest. So we would rewrite this problem as x minus 3 in 2, and we'd rewrite that expression as well and put it in order. And you'd have to do this whether this was synthetic division or long division that we were going to use. Okay, so that's rewriting the problem in long division form. For synthetic division, we basically just use the coefficients and then use a little algorithm on those coefficients. So we start off by making a little box, and I always remember this as x box. The x goes in the box. In other words, the x that would make this expression 0 is what goes in the box. So this is x minus 3 is a possible factor, so the x goes in the box. In this case, that's 3. So again, if x minus 3 was a factor, what would the 0 be? What would your x equal? So that's where that 3 comes from. And then the rest is going to be coefficients on each term. This is cubic, so we start with it to the third. The coefficient there is just 1. It's 1x to the third. 2x to the second, minus 5x, and minus 6. Watch out here if there's any missing terms. If we had, let's say, an x cubed but no x squared, you'd need to put a 0 in for a placeholder. Okay, so that's how we set up our synthetic division. I leave a space, I draw a line, and now it gets super easy. Watch what we do. We always bring down that first number so the 1 comes down, and then all we're going to do is multiply and add. So this number times the number we just brought down, 3 times 1, which is 3. So multiply, put it there, add, and then do it again. Multiply, 3 times 5 is 15, add, that's 10, multiply, 3 times the number I just got, 10, which is 30, and then add, and that's 24. This last number is your remainder, and the rest of these numbers are the coefficients on your answer. So a couple ways to keep track of what's going on with the x's here. First, the easiest way for me, what I like, is if I know this is the remainder, then it's constant, x to the first, x to the second. So you can kind of go right to left. So that's going to be 1x squared plus 5x plus 10 with a remainder of 24. And you'll remember we write that as plus 24 over the x minus 3. And if you wanted to do long division to double check that that's in fact the same answer, you could, but synthetic is much, much easier. And that is how you do synthetic division. Now let's look at another example. In fact, if you watched the last video on long division, you'll remember this exact same problem. I'm going to show you how much easier this is with synthetic division. So this one is conveniently already in standard form, so I don't need to rearrange it. Remember the x, whoops, let's do that we'll do it in blue. Why not go crazy and use blue? So the x goes in the box. So this one's a little different because it's a 3x plus 2. So what would make 3x plus 2 equal 0? If you need to write that off to the side, if you're not a do-it-in-your-head kind of person, you could just solve that, but you can probably do that in your head. So negative 2/3, so negative 2/3 goes in the box. Now that's a fraction, but fractions are our friends. Nothing wrong with that. So now I'm going to put the coefficients on each of these terms. I've got it to the fourth. I'm going to make sure that there's 1 for each below that. So to the third, to the second, to the first, and constant. So there's no missing terms. I don't need any zeros. Always got to watch for that. Very easy mistake to make. So I'm setting up my synthetic division, leave a space, draw a line. And now we do the same process. So bring down the 6 and then multiply. So negative 2/3 times 6, so that's negative 12/3, which is negative 4. And if you're not a fraction person and you need to go off to the side to do that, you can. 4 plus negative 4. Remember in synthetic, it's always multiplying and adding, which makes it a little easier. So 4 plus negative 4 is 0. Multiply, left that 0. Add, negative 15. Multiply, negative 2/3 times negative 15. That's 30/3. 30/3, positive 30/3, which is 10. Add, we get 3. Negative 2/3 times 3 is negative 6/3, which is negative 2. Add, and I get a 0 remainder. A remainder of 0 means that 3x plus 2 is a factor of that nasty expression. It goes in evenly, and this is what's left over. But there's a catch. You knew there had to be a catch. This is pre-calc, not algebra 2. When you use synthetic division, and the thing you're dividing by, if the coefficient on x is something other than 1, you've never seen this before most likely. If this is something other than 1, like it is here, it's a 3, you have to take your result and divide it all by 3. So you have to divide all of those numbers by 3. So your final answer, that 6 divided by 3 is 2. That's a 0. Negative 15 divided by 3 is negative 5. 3 divided by 3 is 1. And the 0 is still 0. And so these are the coefficients of your final answer. Remember, that's remainder constant to the first, to the second, to the third. So it's 2x to the third. 0x, I don't need to write that. Sorry, 0x squared minus 5x plus 1. And that is your final answer. There's no remainder, and we're done. And that is how we use synthetic division in pre-calc. Good luck.